So today we are going to look at the measure of dispersion for group data, the second part of dispersion. So previously we learned 7.1 already, the dispersion on how to construct histogram and frequency polygon. Do you remember when we want to construct histogram, what is needed? What is needed to construct the histogram?
All the data?
We need we need the upper boundary and the lower boundary to construct histogram. After that, to construct frequency polygon, we just go through it just now. What do we need to construct frequency polygon?
Midpoint.
Correct, midpoint. But then you have to remember, you need to add on a class before and after it with a frequency of how much?
0.
Correct, with the 0 frequency, so that your frequency polygon won't be floating like that. It will be on the line, the axis like that. Okay, and then we also learn on how to compare and sorry, this one haven't. This is what we are going to learn. We are going to see on how to compare and interpret the dispersions based on histogram and frequency polygon. So you have done these two before, but then today we are going to interpret the dispersion. And the last thing is we are going to see on how to construct an ogive for a set of group data. So over here, this include the quartal, the first quartile, second and the third quartile, and also the percentile. Okay, and then in the next lesson, we are going to enter 7.2, the measures of dispersion. So on this full subtopic for this chapter. Okay, let's see on how to construct, not how to compare and interpret the dispersions based on histogram and frequency polygon. So to compare and interpret over here, we need to look at the shape of the histogram and the frequency polygon. So we are going to see the distribution shapes of data. Okay, now we move down here. So what is the meaning over here? Distribution is symmetric if the shape and size of the distribution are almost the same when divided into two parts, left and right. So if you look at left, when you divide, they are almost symmetry. So it's almost the same as the right. We say that these are symmetric histogram. Same with this one. The left is more or less the same as the one on the right. So we call it symmetric histogram. The first diagram there, we called it the bell-shaped histogram because it looks like the shape of the bell, like this one. Okay, and then the second one, we called it uniform-shaped histogram. The shape is almost uniform. So you remember this word, okay, bell-shaped and also uniform shape. They are under the category of symmetric histogram because they look almost the same when divided into the left and the right. Okay, we move on. Now we have a second one. The shape of the distribution is skewed if one tail of the histogram is longer than the other tail. So do you know the meaning of skewed over here?
No.
No, dalam bahasa Melayu dipanggil you remember this, So if we have this part on the right is skewed, sengit ke sebelah kanan over here, so we called it right skewed. These are the skewed histogram. And then this part sengit sebelah kiri, so we called it left skewed histogram. Are you okay? Are you doing? Yes. Okay, then we look at the right over here. We have some more to go. So there are a few types over here. These are the extra from your book. This one look like U, so it is called a U-shaped histogram. This one here, it looks like a J shape because you start from the top over here, J shape. The third one is the reverse of J shape from the top over here. Okay, reverse J. And the last one over here, we called it the bimodal histogram because we have two mod over here with the highest frequency. Okay, so this one is bimodal. This one reverse J shape, and the one before is J shape, and we have U shape. Okay, now you look at the diagram here that I have. Can you observe carefully each of these is under which category? The first one. This one is what?
Bell shape.
Bell shape.
Alright, this is the bell-shaped histogram. What about this one?
Left skewed.
Yes, very good. Left skewed histogram. And then this one?
Right skewed.
Right skewed.
Right skewed. Okay, good. What about this?
Bimodal.
Very good. You understand they have two modes over here. So this is the bimodal histogram. What about this?
J shape.
J shape.
J shape. Okay, the J shape histogram. Can you guess what is this one? Because we just now we didn't go through this one. This is extra actually. We learned the U shape, right? This is reverse U shape. Okay, the balik. Now I move on. So you know how to identify the skewed and also the symmetry histogram. There are two categories only, the skewed and also symmetry. The symmetry. Now we look at example 5. We need to interpret the data over here. So you look at the example here. The diagram below shows two histograms representing the time taken by 25 swimmers to complete two different events. The first event is 100-meter backstroke. How many of you can do backstroke? Raise up your hand. Let us see. How many of you can do backstroke? Wow, Hedy can do backstroke. Anybody else?
I don't know whether I can anymore.
Oh,
Yeah.
yes, you can before, right, Faiz?
Yeah.
Well, Ikla also can. Numan also can. Wow. Matthew, I can barely float. Yeah, Irfan. Okay, Muhammad Aiman. Wow, a lot of you. Okay, that's great. Now we continue. So besides the backstroke, they have 100-meter freestyle. I think, of course, if you know how to backstroke, you for sure you can do freestyle. Okay, so this represents the number of swimmers over here, means that's the frequency. Okay, and then this part representing the time. So both graphs are the same, on the x and on the y-axis. Now we look at the question here. A, set the distribution shape of the histogram for the two events. So we need to look at the two events over here for the 100 meters backstroke and also the freestyle. What is the distribution shape? We just learned the shape, you remember? So what shape is this?
Bell shaped.
Bell shape.
It's bell shape. Okay, bell shape histogram. So the backstroke, 100-meter backstroke shows a bell shape distribution. What about this one?
Uniform shape.
Uniform
Yes.
shape.
Very good. This is uniform shape distribution. Okay. Now we look at B. Which event has a wider dispersion of time taken? And then give your reason. So now we need to look at the time taken over here. Okay, so this one, the time taken, to find out, you can use 104.5 to minus 69.5. Okay, so you can roughly get the answer, 104.5 minus 69.5, we will get about 35. Whereas for the second diagram over here, freestyle, I have 69.5 until 89.5. So you can guess already, right? Which one has a wider dispersion?
Meter backstroke.
Yeah, the backstroke has a wider dispersion because the time taken is longer over here. It disperses more. Okay, give your reason. So give your reason. You can just say that because the difference of the time recorded here is larger. Okay, that is how many seconds? Then we get already just now, right? It's about 35 seconds. Is it correct over here? 35 seconds, 10.5 minus 69.5. Yeah, 35 seconds. Okay, now next. C. Between backstroke and freestyle, which event did the swimmer perform better? Between backstroke, this backstroke over here, and the freestyle. Which event did the swimmer perform better? If you look at this one, we have one swimmer perform just about the time here, from 69.5 to 74. And then we have 3 swimmers perform from this range. And then we have 6 swimmers perform at this range. This one, 7 swimmers. But then when you compare with the freestyle here, we have 6 swimmers at this range, 6 swimmers, and then 7 swimmers, 6 swimmers. So in which event did the swimmers perform better?
Meter
Freestyle.
Yes, this one, the 100-meter freestyle. Okay, this is because most of the swimmer over here, they record a better time given. Okay, now, can I continue?
Yes.
Yes, okay, let's continue. Okay, what is this diagram here? What is this diagram? You have learned to draw this.
Frequency polygon.
Correct, this is frequency polygon. Okay, now we look at the given information. The frequency polygon below shows the selling prices of the houses that were sold in 2 different areas in the last 6 months. So this is the selling price of houses in area A and area B. You can look at the red line here to represent the area A, and then the blue line represent area B. Okay, with the selling prices indicated for the x-axis, and this part y-axis represent the number of the house units. Okay, which also represent the frequency Now we look at the question. A, set the distribution shapes in the 2 areas. So you need to set the distribution shapes in the 2 areas. What is this shape here for the red one?
It's skewed.
Yeah, skewed to the
Right.
right or left? Just want to test you only. Right, right?
Right.
So this is a right skewed graph. Okay, what about the area B here?
Left skewed.
Yes, left skewed. Okay, so you just need to mention about the distribution shape of area A over here is skewed to the right, whereas for area B over here is skewed to the left. Okay, now we look at B. Compare the dispersions of the house prices in the 2 areas. So when you were asked to compare the price, how do you compare the dispersion of the price? You just need to look at the first one, the first point over here till the end. Okay, so for example, this area A over here, I'm going to see how many parts of the prices is divided. So this is half. Plus this becomes 1.5, 2.5, 3.5, 4.5, 5.5, 6.5, 7.5, 8. So it's spread at different selling prices. And then if we look at area B over here, half, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5, 7.5, 8. So they are the same, right? Meaning the dispersion of the selling price in the area A and also area B are the same, even though their shape is different over here. Almost the same although we can see the distribution, the price over here is a bit different because this part is higher and then this one is lower. It starts at the lower selling prices, but they are approximately the same. Okay, C. In your opinion, which area represents an urban area and which area is a rural area? Which one is urban area? Can you see? If you look at the price, of course, the higher cost of the house will be urban area, right? So area A or area B is urban area.
B.
Yeah, area B represent the urban area. So meanings area A represent what area?
Rural area.
Rural area because the house is cheaper over here. Okay, so that is how we compare and interpret the distribution of data. So this part is done. Now we are moving into how to draw ogive. Okay, so let us see at the second part. Okay, briefly go through with you the steps to draw an ogive, construct an ogive for a group data. First, you have to add one class before the first class with 0 frequency. Same as which one?
Frequency polygon.
Correct, same as frequency polygon. And then find the upper boundary and the cumulative frequency for each class. So we have to find upper boundary and also the cumulative frequency. Then choose an appropriate scale on the vertical axis to represent the cumulative frequency. and the horizontal axis to represent the upper boundary. So you have to know this one, the vertical represent the cumulative frequency and the horizontal represent the upper boundary. After that, you plot the cumulative frequency with corresponding upper boundary and then draw a smooth curve passing through all the points. So let us look into the question over here later on. Okay, we look at quartile first. For a group of data N, the quartiles can be determined from the ogive. This is like what you learned in Form 4. First quartile, second quartile, and third quartile are the values that correspond to the cumulative frequency N over 4. So N over 4 over here, it can be 1 over 4 times N. And then N over 2, it means 1 over 2 times N. This one, same thing, 3 over 4 times N. Okay, so when you want to find the first quartile, it's actually 1 over 4 times with the total frequency. So the total frequency over here is referring to N, total frequency. Okay, now we look at example 7. So this is example 7. The frequency table on the right shows the salt content of 60 types of food. So I think you will never imagine how much is the salt content for the food that you have consumed. Okay, so these are the salt content for the frequency. For number of food, the salt content is 100 to 149 and so on. So you can see the last one types of food, the salt content is so much. Okay, A, they ask you to construct an ogive to represent the data. So to construct the ogive, remember just now, we need the upper boundary and also the cumulative frequency. Okay, so you can see from my diagram over here, you just need to add on the upper boundary and the cumulative frequency. The rest is the same. Okay, then we need to add on one class before. Remember that? Before the first class with 0 frequency. So you got to imagine over here, not imagine, you have to think of how to get the first class. So each of the different from the class, you can see how much is the difference for this class? How many data in here?
50.
50, right? Meaning the last data for the first class over here should end at how much? If all of it ended with 9, so this will be before 100 is
99.
99.
correct, 99. And then you know that the 50 data in one class, so this will range from how much to 99?
50.
Very good, 50 to 99. We will have 50 data over here. So remember what is the frequency?
0.
Frequency? Yes, frequency should be 0. Okay, now we are going to look at the upper boundary. To get the upper boundary, it is the upper limit plus the lower limit, you divide by 2. So 100 plus 99 divided by 2. What is the upper boundary?
9.5.
0.5. Okay, we just carry on now. For this one, it will be 149.5. You just need to copy from the left there. 199.5. This one is 249.5. 299.5. Anybody doesn't know how do I get this? Hopefully you know. I just take all of this here and then I add on with 0.5 only. So this is 399.5. Okay, now we are going to calculate the cumulative frequency. So first one must be 0, right? Because we have the 0 frequency in the first class here. Followed by 4, so 4 plus 0, still 4. Okay, now I'll call your name. Imran, are you here? Imran? Quiet down. Okay, never mind. Irfan Zikri.
Imran is here. He's saying the chat.
What did he put down? Can you tell me what is the cumulative frequency for this one, Imran? 0, 4 followed by this means you have to add up with the 11 over here. How much is the cumulative frequency? You cannot talk, is it? Yeah, Imran. No answer from you. 7 ka, correct or not, class?
15.
It is 15
15.
because
4 plus
we need
11.
Yes, very good. 4 plus the frequency after it, so it will be 15. It's not 7. I wonder how you get the 7. Oh, because you use 11 minus 4, that's not correct. Cumulative frequency over here, maksudnya frequency yang telah terkumpul. You have to accumulate everything. So 0 plus 4, we get 4. 4 plus 11, we get 15. 15 plus 15, how much?
30.
30.
30, correct. And then we are going to add on 30 with 21 will be
51.
1.
1 plus the last one, 51 plus 8,
59.
59.
9. Okay, there's one more line at the bottom, one row. So 59 plus 1,
60.
60.
yeah, 60 altogether. Okay, so after that, we can plot our ogive already based on the upper boundary and cumulative frequency. So upper boundary is on the y-axis or x-axis?
X-axis.
Correct. So meaning cumulative frequency is on the y-axis. Let us look at the graph. The graph is plotted on the right. I just show it to you. So we have this graph plotted. Okay. Now you look at all the upper boundaries. So it starts with 99.5 and with 399.5. So this is what we have. Make sure you use the uniform, the correct or the uniform scale. So meanings 2 centimeter represent 50 here, 99.5 until 149, and then 199, and so on. Whereby for the cumulative frequency, same thing is on the y-axis. We are going to start with 0, and then you just observe the number that we have. Total, we have 60. So you have to, because they didn't give you the scale, you have to be wise on how to divide it. 60, we are going to use 2 centimeter to represent 10 over here. Okay, 10, 20, 30, 40, 50, 60. Now, after you have plot down the x and the y-axis, you are going to plot all the frequency, cumulative frequency. So 0 is here, followed by 4, this is the 4, followed by 15, this is 15, followed by 30, 30, followed by 51, 51. After that, 59, 60. So lastly, you join it with a smooth curve until you get the smooth one. Okay, make sure you always get the smooth curve like this. So you can see actually this is half of the bell shape. Okay, if we add on another half, it will be this way. So you are going to get the bell shape. Now, from the, this one, we call it ogive. From the ogive, they give you the question over here. You look at B. I'm not sure whether you can see or not. I'll put it nearer. Okay, from the ogive, determine the first quartile. Do you remember what is the formula to get the first quartile? First quartile, I write down now. Yeah, it is 1 over 4 or n over 4. So n over 4 will be equal to 60 because the total data is 60, right? The total data is 60, yeah? So we divide by 4, we are going to get 15.
15.
Correct. So 15 is not our first quartile yet. You have to refer to the cumulative of 15 over here and then plot it to the right with dashed line. Plot it to the right and join it down. Okay, you are going to get 199.5. So the value for the first quartile is 199.5 mg, milligram. Okay, any question?
No.
No.
We move on to the median. So the median here is actually the same as the second quartile. Okay, so we are going to look for the second quartile. The formula will be n over 2 or 1 over 2 times n. So it will be 60 over 2. We are going to get 30. Then you refer to 30. 30 is here. So use the dash line. You must use dash line. Draw to the right until you meet the ogive. Okay, and then draw down there to get the value. So the value is 249.5. So second quartile, okay, we are going to get 249.5 mg. Okay, now we look at the last question here, the third quartile. So the third quartile, the formula is 3 over 4 times n over, 3 over 4 times n, right? So it will be 3 over 4 times the total value of 60. 3 over 4 times 60, we are going to get 45. 3/4 of 60. That's why we have this. So same thing, you draw using dash line, move down. Okay, how to read this value? It's up to you. You can read slowly from here, or you can just minus using 299.5 minus 249.5. So actually, you already know that 299.5 minus 249.5 is actually equal to 50, right? And then we have 10 parts in between. So you need to find out one part represent how much? It represents 5. Okay, so now you refer back to this. From here to here, how many parts do we have? 1, 2, 3, 4, 5, 6, 7, right? So you can just using your calculator 5 times 7. You get 35. After that, add on with 249.5 plus. That's how we get the answer of 2 at 4.5. So the third quartile, we have 2 at 4.5. Do you understand, class?
Understand.
Yes.
Yes, huh? Okay, then I continue. Okay, I'm going to continue with this one. Okay, this is also in your book. Cumulative histogram and ogive can be constructed using cumulative frequency table. Okay, so this is a cumulative histogram. That's why you can see a cumulative frequency. Usually we just draw a normal histogram without the cumulative word. But now if you draw the cumulative histogram, you have to use a cumulative frequency. So it is constructed just like histogram, but the vertical axis is represented by cumulative frequency. So that is the meaning. The vertical axis over here represented by cumulative frequency. Else it is represented by what? The normal one is represented by what? This part. The normal histogram is represented by frequency only. Okay, that is what you have learned before. Now, they ask you to refer to example 7. Example 7 is the one that we did just now. The cumulative histogram and the related ogive are as shown below. So, this is the example 7 that we have just now. Do you see the similarity?
Yes.
Yes, right? Okay.
Yes.
Yes, right. So it's the same thing actually. Now we look at the question. What do they want us to find out? How is the construction of ogive related to the construction of cumulative histogram? Can you find how do they related? Can or not? I show to the example 7 to you one more time. This is example 7. You can see from the table the upper boundary. You get this with the cumulative frequency. Now, if you look at this one, so how is the construction of the cumulative histogram? What is related? Can you answer? What is the same here?
Cumulative frequency.
Yes, very good. The cumulative frequency. And one more thing, what is the same? The upper boundary. Can you see that?
Yes.
So what you need to do next time, if you don't have this, you can construct ogive from a cumulative histogram. How to construct it? What you need to do, you just need to draw all the cumulative frequency, plot all the cumulative frequency on the histogram with the upper boundary that is related. Okay, then you can draw your ogive. That is one of the method lah. Okay, so now we move on. So just now you learned about quartal. Now we move on to percentile. So this is a new term to you. Okay, let's see what is a percentile. We can analyze the large data more easily and effectively when we divide the data into small parts, which is known as percentile. A percentile is a value that divides a set of data into 100 equal parts and is represented by the first percentile, the second percentile, the third percentile until the 99th percentile. So you have to memorize this. Percentile is a value that divides a set of data into 100 equal parts. Okay, so I give you an example now. For example, if I have 50 data, now if I want to find the first percentile, so the first percentile will be the data itself. You divide by 100 because it is divided into 100 equal parts. Okay, and then you are going to multiply by 1 because we want to find the first percentile. So the answer will be 5 divided by 10 equal to 0.5. So 0.5 is the first percentile. What if we have we have 200 data? Can you find the first percentile?
2.
Yes, very good. You got it fast. So 200, if you can get it fast, you don't have to do this calculation. This is just to let you know. I multiply by 1 to get the first percentile. So the answer is 2 if it is 200 data. If it is 1000 data, what is the first percentile?
10.
Very good.
10.
Will be the first percentile. Okay, let's move on. There's a little box over here. 25th percentile is also known as the first quartile, 50th percentile as the median, and 75th percentile as the third quartile. Can you understand this?
Yes.
Yes.
Huh?
Yes.
This is in the first quartile, so 25th percentile is the first quartile, 50 is the median, and 75 is the third quartile. So you understand this one? Then I move on. We are going to apply the percentile to the question given. This one. Example 8. I think this is the last example. Okay. The ogive on the right shows the scores of an aptitude test. Do you know what is an aptitude test? Aptitude test.
No.
Yes.
No.
No.
After we
Some of you say
PT3.
yes. Pardon?
After we PT3 the other day, right?
After your PT3. No. This is different. It is obtained from candidates who are applying for a post in the company. Aptitude test, sometimes when you apply for a post in anywhere else, they are going to test you to see your performance. There are all kinds of tests. There could be a mathematics test. There could be a shape identification to see whether you can get the shape very fast. They can give you some other tasks to see how can you solve that task. So these are the aptitude tests to see how do you perform and then whether you are going to be accepted or not. Okay, so we call this aptitude test. It's a test for you when you want to join a company, but not all company will do that. Maybe a very competitive company that will do that. Okay, now we look at the question here. A, based on the ogive, find the 10th percentile, 10 percentile, P10. And then the 46th percentile, P46. So from here, we are going to find the percentile. How do we find? This is the ogive. Okay, this is the ogive on the right. Okay, P10 over here means we are going to find the 10 percentile. So 10 divided by the total frequency. How much is the total frequency that we have if you look at the ogive that we have here? How much?
60.
It's not 60. You look at the maximum point here. Yes, it is 50. So to get the 10 percentile, we use 10 over 100. You multiply by 50. 50 is the frequency. So we are going to get 5. From there, to get the 5, we are going to refer to the ogive. It's quite late already, so I'm going to move faster. So refer to the 5 over here. You are going to move until you meet the ogive, and then you move it down, and you get the reading. So how to get the reading? This is 40.5. This will be 41.5, 42.5, 43.5, 44.5, 46, 45.5, 46.5. So the value over here, that is how we get the 10 percentile is 46.5. Are you okay, class?
Yes.
Yes, huh?
Yes.
I move on, huh? So for the 46 percentile, you are going to use 46 over 100 times 50. So we see you are going to get this. Okay, so you need to refer to the 23rd frequency over here. The cumulative frequency 23 is right here. So same thing, you are going to move to the right. Make sure you use ruler, huh? And then you move down. So then you read from there. The reading that you are going to get is 63.5 over here. 63.5. That's how you get the 46 percentile. P46 is equal to 63.5. Okay, now I move on to B. Only those candidates who obtain 92nd percentile and above will be called for an interview. So what is the minimum score required in order to be called for an interview? Therefore, how do you get the 92%? To get the 92%, you have to divide by 100 times 50 again, right? So you are going to get the 46. Okay, to get the 46 over here, you have to find the score. You have to refer to the 46 cumulative frequency here. Okay, so you move. 46, huh? You keep moving until you meet the ogive. So if I enlarge the ogive, your book, you cannot enlarge. If I enlarge the ogive, it will meet somewhere in between here. So we cannot choose this on the right, we cannot choose on the left. So we have to choose the one exactly in the middle. In the middle, sorry, my line already moved out of the direction. Here. So from here, you are going to read it as 71.5, 72.5, 73.5, 74.5, 75.5, 76.5, 77. That is how we get a 77 over here. Okay, not class?
Okay.
Okay,
Yes.
So for the 92 percentile, you can see here, the candidate with a minimum of score 77 will be called for an interview. Meaning over here, for those candidates who get less than 77, they won't be called for the interview. Okay, so we continue with the last question. Okay, last question. What is the percentage of the candidate who obtain a score of 57 and below? So same thing over here, we need to find out how many candidates get 57 and below. So to get 57 and below, what do you do? How to get the one with 57 and below? You just need to refer
To the
ogive.
to the ogive. So how many candidates have a score of 57 and below? You just refer to this ogive over here. 57 is somewhere over here. So this is 51, 55, 56, 57.5. This is 57, is over here. Okay, and then you just need to move to the left. Okay, when you move to the left from here, use dash line. Sorry, you are going to get how much? How much is the
15.
Yes, it is 15. That's why you will have the answer written like this. Okay, from the ogive, 15 over 50 times 100 is 30%. Do we need this? Oh, yes, because they want you to find the percentage. So after you get 15, you divide by the total frequency and you multiply by 100. Okay, so therefore, 30% of the candidate obtain a score of 57 and below for this one. Okay, so now we are at the end of our lesson already. Make sure you submit your work in the GC. Okay, what I want you to do today is just 7.1B and 7.1C.